Welcome to my first video on graphing trig functions. In this video I'm going to focus mainly on the sine function. From here I will do a video on cosine, tangent, cosecant, secant, and cotangent, and then I will get into separate videos on transforming those functions with phase shifts, amplitude changes, vertical translations, and period changes. From here though, I just want to basically just do sort of an intro video on the sine curve and talk a little bit about some of these really key points about the sine curve. So let's get started. So when we talk about sine, cosine, and tangent, right, these are just functions, right? F of x is equal to a function, right? In this case it's sine. So what that means is you're going to input an x value, and when you do sine to that x value, out comes your y value. Alright, so you input a domain value and out comes a range value. Right, so the input-output idea is nothing new. Right, we can replace f of x with y, and this is just sort of a mapping from x's to y's. It just so happens that this sine curve is very cyclical. It's extremely useful not only in trigonometry, but you can also apply it to the real world in a lot of different ways. Alright, so let's go ahead and get started. My job here is to graph one period of the sine function on this graph. And before we do that, I want to start thinking about like some key points. All right, I want to think about like where the sine curve starts. So what I always think about first is like where the graph starts. And I know the sine curve starts at 0, 0. In other words, the value when you plug in 0 to sine is 0. F of 0 is 0. Alright, and that comes back to our idea of the unit circle, which we've studied before in previous videos. On the unit circle, remember this is the radius of 1, right? Which means that this point right here is 1, 0. Alright, so if we're talking about 0 radians or 0 degrees, right, it's basically just the positive x-axis, right, this line right here. And I know that the sine of 0 is 0 because in these coordinate pairs, these ordered pairs rather, the order is cosine comma sine. In other words, the y value is always sine and the cosine value is always x. Cosine is always x. So, and that kind of comes back to this idea, like if we were to draw a sort of reference triangle, right, and look at this angle theta. Well, I know that this radius is 1 because the radius is 1 all the way around the unit circle. So let's assume this distance is x and this distance is y. Well, that means that this point is x comma y. Right, and if we think back to our sine, cosine values, right, the sine of an angle is opposite over hypotenuse. So it's opposite, sine of theta is opposite over hypotenuse. It's y over 1, which is just y. So that's why the sine is y. And the cosine, of course, was always given by adjacent over hypotenuse. Well, adjacent in this case, adjacent of course means next to, so it's x over 1. X over 1 or just x. So that's why cosine is the x value. Alright, so getting back to the sine of 0 being 0, this point here on the terminal side of this 0 degree angle is the point 1, 0. And the sine is the y value there. So the sine of 0 is 0. In other words, it's the up and down direction of this point. How far does it go up and down from the x-axis? It doesn't go up and down any, so the sine of 0 is 0. If we go up to this one, let me erase some of this. If we go up to the pi over 2 angle, the pi over 2 angle was, of course, right here. So that's given by the point 0, 1. So when the degree is pi over 2 or 90 degrees, the sine of pi over 2 is 1. It's the up and down direction. In other words, it goes up 1 unit from the origin. Moving along, we have over here we have pi radians, or 180 degrees. Well, this point, again, we're in the unit circle, so it's -1, 0. The sine of pi is 0, because this point goes up and down nothing. Down here we have the ordered pair 0, -1. Right, so the sine, this is 3 pi over 2, or 270 degrees. So the sine of 3 pi over 2 is -1. And then we get back here to 2 pi, and the sine of 2 pi is back to 0. Alright, so the sine of 2 pi is back to 0. So I'm going to highlight these. Right? Let me rewrite the sine of 0 is 0. So I have 1, 2, 3, 4, 5 key points. That's where I'm going to get my sine curve from. So let's graph those points. Right? 0, 0 we already have. Let's go to pi over 2, 1. Pi over 2, 1. So I'm going to have to, let me get rid of this. I'm going to have to label this as pi over 2. This would be pi. That means this is 3 pi over 2. I'm labeling my x-axis in radians. And let's make this +1 and this -1. So we already plotted our first point there at 0, 0. The next point is pi over 2, 1. The next point is this x-intercept right here, pi, 0. 3 pi over 2, -1 is a point, and 2 pi, 0. Alright, so let's graph this. Let's connect these dots. This is one period of the sine curve. Alright, and after that it just keeps repeating itself. So it would go like this again. And before that it would keep repeating itself, so it would go like this again. Forever and ever. Right? This is a periodic function. It goes on forever. The period is the distance it takes to complete one cycle. That's 2 pi units. So from here to here it repeats or completes one cycle, so that's 2 pi. The amplitude is sort of the distance from the middle, in this case the x-axis, to the top. So this is our amplitude. That's 1 unit. Amplitudes are always given in positive units. Another way to think of the amplitude is if you just literally sort of count the up and down distance of the entire graph, that would be 2 units. Just cut that in half and you get your amplitude. Amplitude is basically half of the entire height of the graph. The domain of this graph, of course, is the left and right coverage. It goes on forever, -infinity to +infinity. The range is the up and down sort of coverage. So it goes, of course, from -1 to +1. It keeps bouncing back and forth between those values as y values. So we're going to put that in closed brackets. The x-intercepts, of course, 0, 0, pi, 0, and 2 pi, 0. And then it would just keep repeating every pi units forever and ever. The maximum would be pi over 2, 1. That's the highest point on our graph. And these points are just for this main cycle of the function. The minimum, of course, is the lowest point on the graph. I would say that that's 3 pi over 2, -1. There are no asymptotes. The phase shift, not in this case. We're going to use all these in a little bit. There's no vertical shift and there's no reflection. We'll use all these when we get to, or these three rather, these transformations, when we start getting into changing this function up, changing the amplitude, period, We'll even reflect a few, change the vertical translation, stuff like that. So there you go. There's the sine function. Pretty basic stuff. You know, a nicer graph would look like this. You know, you can see that we're just looking at one cycle, right? But of course, we know that it goes on forever. It goes on forever, and it keeps repeating itself. So that's the kind of like the basis of all of our sine curves are going to come from this parent sine. In other words, when the sine is not transformed in any way, it looks like this, and this is the basis of all of our future sine curves that have like maybe a number in the front, 2 sine x, or maybe sine of 2x, or maybe sine of x plus pi over 2 or something, or maybe 2 sine x minus 4, right? When we start transforming these things and maybe negating the a value and things like that. So we'll get into like what the a value, the b value, the c value, and the d value all mean in a later video. But there you go. There's the intro to sine. My next one's going to be cosine, then tangent, and then all the reciprocal functions. So thank you for watching.